You're standing in your garden right now. The afternoon sun is baking the back of your neck. Your electric fan inside the porch is humming, eating watts, and the meter on the side of your house is spinning like a slot machine. But what if I told you there's a fan in a small Amish garden in Holmes County, Ohio? That has been running for 11 years straight without ever being plugged into a wall, without batteries you have to replace, and without a single solar panel? $5 in materials, 2 metal plates, a patch of damp earth. That fan moves air 24 hours a day, 7 days a week, and it costs the family that built it absolutely nothing to keep it running. The Amish call this kind of setup ground power, and the only reason you've never heard of it is nobody profits when a man powers his own garden from dirt. I'm going to walk you through the exact build. I'm going to show you the document from 1841 that proved this works long before any utility company existed. And by the end of this video, I'll share a finale technique I found buried in an old United States Department of Agriculture USDA bulletin from 1918 that makes this little battery last not for months, but for decades. And yes, if you already own your house, your yard, your patio, this works for you starting this weekend. The first time I saw one of these, I was standing behind a barn outside Berlin, Ohio, watching a small wooden fan turn lazily over a vegetable bed. No cord, no panel, no sound except the blades. I asked the old man who lived there where the power came from. He pointed at the ground and said, "Same place the corn comes from." I thought he was joking. He wasn't. Here's the truth most people never learn. The earth beneath your feet is a battery. It has been a battery since the planet had water and metal in it. When you bury 2 different metals, one more noble, one more reactive, into moist soil, the soil acts as the electrolyte. Electrons flow from the reactive metal through the wire to the noble metal and back through the dirt. That flow is electricity, free, constant. As long as the ground stays damp and the metals are intact, the current never stops. This isn't theory. This is the same principle Alessandro Volta described in 1800 when he built the first true battery. The only difference is he used a stack of discs and a salt solution. The Amish used the ground itself. In 1841, a telegraph engineer named Carl August von Steinheil ran a long-distance signal line in Bavaria using nothing but the earth as the return conductor. He documented it. The paper still exists. Telegraph companies across Europe and America used earth returns for nearly a century because they worked, they were free, and they were reliable. Then the power industry came along in the early 1900s. Any technology that didn't require a meter on the side of your house quietly vanished from the public conversation. It didn't disappear because it failed. It disappeared because it couldn't be sold. Now let me tell you what you actually need. 1 copper plate, roughly 6 inches by 6 inches. You can buy a sheet of pure copper at any hardware store for about $3, or cut one from old pipe flashing 1 zinc plate the same size. A galvanized steel sheet works, or a sacrificial anode from a water heater, which costs about $2 at any plumbing supply. 2 lengths of insulated copper wire, 12 gauge, about 4 feet each. Total cost, if you buy everything new, sits right around $5. If you have scrap metal in your shed, it costs you nothing. You dig 2 holes in your garden, about 3 feet apart, each one 12 to 18 inches deep. The soil needs to be moist, not soaking, not dry. Clay-rich soil works best because clay holds moisture and minerals longer than sandy soil. You bury the copper plate in one hole, the zinc plate in the other, and you fill the holes back in with the same dirt. You run the wires from each plate up to the surface. You connect them to a small DC motor, the kind that powers a battery-operated garden fan, a USB device, or a low-voltage LED string. That's the whole build. There is no battery to replace. There is no panel to clean. There is no inverter to fail. A single pair of plates buried in good moist soil produces around 0.7 to 0.9 volts and a steady trickle of current. That's not enough to run your refrigerator, but it is more than enough to run a small 1-2 volt fan if you wire several pairs in series. 6 pairs of plates, properly spaced, will give you the steady 5 to 7 volts a USB fan needs. 8 pairs will run a garden ventilation fan strong enough to keep airflow over your tomato plants all summer. Now, if you already own a house and you're thinking this only applies to people building from scratch, stay with me, because this next part is specifically for you. Most folks watching this have a yard. Maybe a flower bed near the porch, maybe a vegetable patch, maybe just a strip of grass beside the driveway. You don't need acres. You need about 10 square feet of soil that stays naturally moist near a downspout, beside an outdoor faucet, or under a shaded bed that doesn't bake dry in July. This is the part the suppression really stings on, because every man over 55 watching this video has been told for decades that running anything outside requires an extension cord. A transformer or an expensive solar setup with a charge controller and a sealed battery that dies after 4 winters? None of that is necessary for low draw devices. A garden fan to circulate air around your plants, a small water aeration pump for a pond or rain barrel, a motion sensor LED on a path, a trickle charger for a single AA cell you can swap into a flashlight. All of these run on the power your dirt is already generating, whether you collect it or not. To retrofit your existing yard, you mark out the spots where the soil stays damp longest after a rain. You bury your plate pairs along that line. You run the wires under a thin layer of mulch back to wherever you want the power, the corner of your porch, the side of the shed, the base of a trellis. No trenching equipment, no permits to pull, no inspector knocking on your door. A garden trowel in an afternoon is all it takes. The Amish families I spent time with in Lancaster County had been doing this for 3 generations before I ever saw it. One grandmother told me her father ran a small fan over the smokehouse this way in the 1940s. When rural electrification was still skipping over their farms on purpose, she remembered the wires, she remembered the metal plates her father pulled out of an old buggy axle. She said the fan ran until her father died, and then her brother dug it up, moved it to his own property, where it kept running for another 22 years. That's the part that should make you stop and think. 22 more years on the same plates, in different soil, with no maintenance. Because here's the thing, nobody tells you about earth batteries. The zinc slowly corrodes, that's how the chemistry works, but in moist clay soil, a 1/8-inch zinc plate can take 15 to 20 years to fully erode. The copper plate lasts essentially forever. When the zinc finally gives out, you dig it up, drop in a new $2 anode, and you're good for another 2 decades. Compare that to a lithium battery in a solar setup. 8 years if you're lucky, then $600 to replace it. But here's where it gets better. And this is the finale I promised you. I spent weeks digging through old agricultural extension bulletins. I knew the USDA used to publish practical farm guides before the agency became what it is today. In Farmer's Bulletin number 942, published in 1918, there's a small section on earth currents and farm applications that almost nobody has read in 100 years. The bulletin describes a technique used by farmers in Pennsylvania and Ohio, and yes, many of them were Amish or Mennonite, to dramatically extend the life and output of an earth battery. The technique is this. You bury a small amount of crushed charcoal, just plain hardwood charcoal, from a fire pit around the copper plate before you cover it with soil. Not around the zinc, only around the copper. The charcoal does 2 things. It increases the surface area of the conductive contact between the copper and the soil moisture by a factor of nearly 4. And it slows the formation of copper oxide on the plate, which is what eventually reduces output in older earth batteries. The bulletin reported that plates prepared this way produced roughly 30% to 40% more current and lasted decades longer than plates buried bare. A handful of charcoal from your fireplace or your grill. That's the secret the energy industry has stayed quiet about for over 100 years. Because once you know that single trick, a $5 earth battery becomes a 30-year power source for every low-draw device in your garden. And the only thing the utility company gets from you is a slightly smaller check at the end of the month. The Amish never patented it, they never wrote a book about it, they just kept doing it quietly on their own land while the rest of the country forgot. Now you know. And nobody can take that knowledge away from you again. You didn't lose access to this because it stopped working. You lost it because someone profited from your forgetting. If you're the kind of man who believes that the most important knowledge has been buried on purpose, somebody else could keep selling you what the earth was already giving you for free, you already know what to do next. Here's my question for you. After hearing about that 1,000 918 USDA bulletin, and the charcoal trick, would you try the charcoal enhanced version first, or would you start with the basic $5 build and see the difference for yourself? Tell me in the comments. I read every single one, and I want to know which way you'd go. If this hit you the way it hit me the first time I saw that little fan turning behind the barn in Berlin, Ohio, hit subscribe. Not because I'm asking for it, because there's a whole movement of folks out here recovering what was taken, and you belong with us. The next video I'm working on covers the Amish roots cellar trick that keeps food cold for 9 months a year using nothing. Bury clay pot in a specific direction it has to face. You're not going to want to miss what that direction is. I'll see you there. Before you click away, though, there's something I need to add, because if I don't say it now, somebody in the comments is going to ask, and they deserve a straight answer. The question is always the same. If this is so simple, if it costs $5, if a USDA bulletin from 1918 already laid out the chemistry, why isn't every homestead in America running on buried metal right now? And the answer isn't a conspiracy in the cartoon sense. It's quieter than that. It's the slow erosion of practical knowledge that happens when a country decides convenience is worth more than competence. Think about what happened between 1935 and 1955. The Rural Electrification Act passed in May of 1936 under Franklin Roosevelt, and within 20 years, the percentage of American farms connected to the grid went from about 10% to over 90%. That's not a small shift. That's a complete rewiring of how rural people thought about power. Before 1936, if you wanted light after sundown, you either burned something, cranked something, or buried something. After 1956, you flipped a switch and paid a bill. One generation. That's all it took to bury 1,000 years of folk electrical knowledge under a layer of copper wire and monthly invoices. And the Amish, bless them, they watched all of this happen from the sidelines. The Old Order communities in Lancaster County, in Holmes County, in LaGrange County, Indiana, they made a collective decision around the turn of the 20th century that grid power would change the structure of their families, their churches in ways they weren't willing to accept, so they kept the old ways. Not because they were technophobes, because they understood something most of us forgot. Every convenience you accept from outside your community is a thread of dependence you can't easily cut later. Now here's the part that should make your jaw tighten. A standard galvanized fence post, the kind you can buy at any farm supply store in Ohio for under $4, contains roughly 1.2 pounds of zinc coating on a 5-foot post. That zinc, when buried in moist soil with a copper counterpart spaced about 3 feet away, will produce usable current for somewhere between 18 months and 4 years, depending on your soil chemistry. When it's spent, you pull it up, you replace it, and you start over. The copper rod almost never needs replacing. People have dug up copper grounding rods from farms in Pennsylvania that were installed in the 1920s and found them still perfectly functional. Compare that to the lithium battery in whatever solar setup the big box stores are selling you for $1,200. That battery has a useful life of about 7 to 10 years if you treat it gently, and when it dies, you can't fix it. You replace the whole unit. You ship the old one to a recycling facility that may or may not actually recycle it, and you write another check. The Earth battery doesn't ask for any of that. It asks for a shovel, a Saturday afternoon, and the willingness to believe that your great-grandfather knew something worth remembering. The skeptics will tell you the voltage is too low to matter. They'll tell you it's a novelty, a science fair trick. Ask them why the United States Department of Agriculture printed detailed instructions for building one and distributed those instructions to farmers across 48 states. Ask them why the Amish, who are not fools and who do not waste effort on novelties, still use them today.